Hello everyone, so today I am going to explain the mechanism of halogenation of alkenes. There are two steps in the mechanism of halogenation of alkenes. First step is the formation of carbocation and halide ion. Second step is rapid reaction with anion. So, the first step for the formation of carbocation and halide ion is we need to know who is the nucleophile site. Second, we need to know who is the electrophile site. How can we identify this? Of course, we need to know what is the meaning of nucleophile site. Nucleophile site is a site that can donate electrons. Electrophile site is site that can receive electron. Easy, right? Okay. So that we know, let's identify together. So the alkene given is 2-methylpropene. We need to identify the nucleophile site. Nucleophile site is a site that can donate electrons. Electrophile site here is here, at this carbon-carbon double bond. Because this 2-methylpropane contains a pi bond, a region of high electron density. The pi electrons are more loosely held than the sigma electrons in a single bond. Therefore, this region acts as a nucleophile or a site that can donate electrons. Okay, this is our nucleophile site. Then, we need to identify who is the electrophile site. So, we can identify it here. Between the HCl bond, we know that H atom is partially positive. Cl is partially negative. So, H will become the electrophile site. In the HCl molecule, the H atom is partially positive and the Cl atom is partially negative. Due to the electronegativity difference between them, chloride being more electronegative than hydrogen. So, H atom is an electrophile site. This electrophile site will receive electron. So, we already identified the nucleophile and electrophile site. Next step is the nucleophile site will attack the electrophile site, causing the HCl bond will break and the Cl will become Cl ion. This step is a slow process. The activation energy for breaking the pi bond and initiating the reaction is relatively high, making this step slow compared to subsequent steps. After the nucleophile site attack to the electrophile site, there are a new formation of bond here. That means the H atom from the HCl bond will bind to the carbon at here. Let's say this is carbon number 1, this is carbon number 2. Okay. The hydrogen atom at HCl will bind to the carbon at this carbon-carbon double bond. According to the Markovnikov's rule, the hydrogen atom will bind to the carbon that attach more hydrogen atom attached to it. We can compare here. This carbon number 1 contains 2 hydrogen. This carbon number 2 contains 0 hydrogen. So, according to the Markovnikov rules, the H atom from HCl will bind to the carbon that contains more hydrogen atom attached to it. So, the new formation of bond is like this. What happened to the Cl? It will become Cl ion. Who is the more stable carbocation? Carbon number 1 or carbon number 2? To identify the more stable carbocation, the carbon must have more alkyl group attached to it. So we can see here, this carbon here is more stable because there are 2 carbon attached to it. Compared to this carbon, only 1 carbon attached to it. So we can put plus here. So this is the reaction for the formation of carbocation and halide ion. The second step is rapid reaction with anion. To start this step, we need to take this product from the first step. It will become the reactant for the second reaction. To start this step 2, the Cl ion will become a nucleophile site. That means the Cl will be a site that can donate electrons. So, this step 2, fast reaction occur. And then the Cl ion will attach to this carbon.